All right, we are back with more Advent of Code. Yesterday, we didn't quite finish 16b. There's some off by one error that I'm still working on, but I don't want to spend the time on the stream to do that. Instead, want to start in on day 17, which at a glance looks like Tetris, but with elephants. So let's see. Day 17, Pyroclastic Flow. Your handheld device has located an alternative exit from the cave for you and the elephants. The ground is rumbling almost continuously now, but the strange valves buy you some time. It's definitely getting warmer. Probably share this. It's definitely getting warmer in here, though. The tunnels eventually open into a very tall, narrow chamber. Large, oddly shaped rocks are falling into the chamber from above, presumably due to all the rumbling. If you can't work out where the rocks will fall next, you might be crushed. The 5 types of rocks have the following particular shapes, where pound is rock and dot is empty space. Sure. Interesting. For parsing, that's, I guess, hopefully I don't need to parse that because it's a little annoying to parse. But okay, they have those 5 shapes. The rocks fall in the order shown above. First the minus, first the minus, then the plus, and so on. Once the end of the list is reached, they repeat. They don't spin, but they do get pushed around by jets of hot gas coming out of the walls themselves. A quick scan reveals the effect the jets of hot gas will have on the rocks as they fall. Your puzzle input. For example, suppose this was the pattern. Push left, push right, sure. Tall vertical chamber is 7 units wide. Each rock appears so its left edge is 2 away from the left wall, and its bottom edge is 3 units above the highest rock in the room, or the floor if there is one. Okay. After a rock appears, it alternates between being pushed by a jet of hot gas, 1 unit in direction indicated from the next symbol in the jet pattern, then falling 1 unit down. Sure. Any movement would call part of the rock to move into the walls, or floor, or a stopped rock. The movement instead doesn't occur. If a downward movement would have caused a falling rock to move into the floor or an already fallen rock, the falling rock stops where it is, having landed on something, and a new rock immediately begins falling. Sure. Tetris. To prove to the elephants that your simulation is accurate, they want to know how tall the tower will get after 2022 rocks have stopped. Okay. Seems reasonable to me. Whoa. Does this have any lines in it, really? Okay. Let's do it. New file. Input 17. Okay, no, it doesn't. Cool deal. It is snowing here. Not very bright outside. Improve the lighting a little bit. That looks a little better. Okay, let's do it. So this is essentially a modeling problem. Shouldn't be too bad, I don't think. So let's get rid of the shortened input. Let's write a function for the example input. Which can just return a string in this case. And it will return the thing from the question, which is this. And for problem A, we want Start equal solve problem 17a, get example input should be equal to 3068. Okay. And we are going to parse a single string, I think. And good. And then the reason this is yelling is because it takes a vector of strings by default. We want it to just take a single string. Returning a usize seems fine. Okay. Okay. So basically, we want this to be a simulation where each step either blows a rock, moves a rock, or causes a new rock to fall. So something like test simulates, and let's say let simulation be simulation new example input. Clearly there are some parameters that we could inject, but I think we'll just make them core to the simulation. So let's say should be mute. So simulation.step and then let's assert that let's see here, get n falling, get n rocks should be 1. Go ahead and assert that this is 0 here. Let's assert get rock position, falling rock is some, and so it's going to be, so it starts 7 units wide. Starts its left edge is 2 away from the left wall. So that should be 2 away from the left wall means that it starts at 2, because 0 and 1 should both be taken, and 3 units above the floor, was it? Highest rock in the room or the floor. Do we want 0 to be, I guess that's 2. its left edge and its bottom edge is 3 units above. 0, 1, 2. Yeah, so it should be 3. Right, because we want 0 to 1. It's bottom edge, yeah. So 2, 3. Okay, simulation dot step again, and what should happen? It should be blown to the right, given the input. So we would want that to still be true, but it gets blown to the right, which means this becomes 3. And then we'll do it again. It should fall now. So this should be 2. We'll do it again. And it goes to the right again. We do it again, it's gonna go down. Let's see here. Let's just say, simulation dot step until lands, rock lands. We'll say so falling position had better be 0, and then it goes right. So it goes right, it falls 1, it goes right, it falls another, it goes right, it falls a third. So it's going to go to 5, 4, 2, 4, 1, 5, 1, 5, 0. So we expect this to be 5. And let's also say insert simulation dot steps, so time elapsed, and this should be an even number, should be 6. Okay. Let's also say, get and rocks. Let's also say assert simulation get falling rock type, and it will be rock, and we'll call this we can call this minus. Okay, and we'll measure the rocks from their bottom left corner. Whoops. Okay. And then still here, we'll say the same thing. Should still be true. And then simulation.step. now the number of rocks will be 2. Oh, we should, well, do that in a second. Falling position should be the same as before. It should be the starting position, which is 2, 3. Time elapsed should be 7. And the rock type should be plus. And then here I also want to say assert, actually even here it should be true, assert simulation dot get height should be 1 because it was the minus. Here that should still be true. And here it should be 0. Okay. And then I guess let's step until the rock lands one more time. And number of rocks should be 2. Falling position. I don't really feel like calculating. I don't think it's that important. Elapsed time I don't think is either. Falling type should be plus still. But height should now be, depends on whether it lands on it or not. Let's see. Can I see it in their answer? False, false, false. Oh, it should come to rest it. Whoops, I forgot that it was going to run into the side. So, 3, 2, 4, 2, 5, 0. Hang on. Pushes, pushes. Pushes rock right, falls 1. Pushes rock right. But nothing happens. So this is actually still 3, 2. And then at the end, it's going to be at 2, 2. 2, 0. Because it's going to get pushed to the left 1. And then when the next one lands, it does land on top of it. Yeah, there's definitely some interesting stuff here. Like detecting the collisions is the non-trivial thing here. Okay, so when it lands, the height should be 4. Let's actually do this. So the position should be 0, 1, 2, comma 1. And the height should be 1, 2, 1, 2, 3, 4. Okay. Okay. And then we're gonna have to do a whole bunch of simulating collisions, I think, because there are some pretty non-trivial ones, but that's all right. Okay, let's go ahead and implement these. So, first of all, let's move this up to the actual thing. And we'll say enum rock minus, minus plus functions here. Let's do all, return a vec of self. It's just this. And we need, okay. So we can repeat through those. I guess we could also say pub function get next. Can I want to just have it do the repeating thing. So probably in the simulation, what we'll do is struct simulation. Rocks will be, can I make this just a repeat of rock? Not one. Oh, it repeats one endlessly. It's not what I want. Alright. I guess it's just next rock. And then time elapsed. Say time is AU size. Hey, Onigomu. How's it going? Thanks for the follow. Nightbot doesn't seem happy with your links, though. How's it going today? Time elapsed. Next rock. And then fallen can be a U size. Unhappy with Nightbot, huh? Well, glad you're fine. And then we'll just keep track of the actual occupied squares, I think. And for this, I guess we can have a hash map. to bool something like this so that we can easily say, is a particular square occupied or not? Seems not unreasonable. And that's nice because it means that the collision logic gets a lot easier. Basically, the rock just needs to know which... Each rock needs to know how to detect collisions with the wall and with the floor by checking. Needs to know which squares to check. So that should be pretty nice. Okay, so let's impulse simulation. Pub function new. And the only thing we want is, oh right, we do need the the wind currents, air currents, is that what it's called? Jet patterns. And that can be a vec of direction. Sure. And then here we'll just say jet patterns, vec direction, will be self, time elapsed will be 0, rocks fallen will be 0, next rock will be starting rock, but it's just rock minus jet patterns, and occupied squares will be a hash map new. Okay. And we could say pub function from string, jet patterns, string, and this just returns self new, jet patterns, chars, filter, C, if C isn't this, or wait, filter to C is equal to this, or C is equal to this. Map. Match C. Then direction left. Direction right. Panic. We filtered down to just these already. Jet patterns, chars, filter. This isn't quite right, is it? Dot map. then we need to close this. Yeah. And let's fix the indentation. Okay. So that gets us from string. Which I don't remember if I did correctly down here. Didn't. Did I use that anywhere else? I think I did. No, I didn't. All right. Cool. So rocks should know how to get the next rock. Next. And let's just match self. Let's take these again. And what's the nice way to do this? I guess we say that we replace all commas with self. We'll start with minus. And then self minus should return self plus should return backwards L, self backwards L should return self bar, and self bar should return self square. Okay. And then let's see here. We need rocks to also know how to get positions, get stone position. And here it'll be at self, and it'll be some rock position, some vec 2, and it will return some vector of vec 2. It could be a hash set. I don't think it matters tremendously. I guess it should be a hash set because I don't want it to have order. That's the problem here. That's fine. And so here we match on self. Actually, you know what we should do is just say self dot get relative stone positions, and iterate over that and say p plus rock position collect, and then relative stone positions can be something like this. Match on self. Let's take all of these. And self minus will be a vec of 0, 0, oops, of vec 2 new. I guess I'm gonna need multiple of these, huh? Okay, let's actually Dot star question mark. And we'll do this new line back of something, new line, and the back of something, new line, this. Yeah. Not quite. Not quite. New line, back, new line, back. Really, I don't need escape characters there. Alright, third time's the charm. Oh, actually, yeah, I don't need square brackets either. Okay, let's just do this. This is easy enough. Okay, back to 0, 0. And then it's a bar that is how wide? 4 wide. So 0, 0, 1, 0. Hey, Kagura OP. How's it going? Thanks for the follow. Doing some advent of code. We have to do a Tetris-like thing where basically show you quickly. Basically, these rocks that look like this are falling from the sky, and jet patterns are pushing the rocks around. It's almost like somebody's playing Tetris, but with these pieces and putting in this input, and we have to figure out how high the tower gets, basically. Hope everything's going well with you. Okay, back to code. And all right, so that's one. At the end of this, I'm gonna have to collect it into the right thing, which is a hash set, which is fine. Okay, and we can get rid of these. It's a little nicer. And maybe even let's do it like that. Okay. And so the plus sign is going to be, what's the plus sign? So it's 0, 1, 1, 0, 1, 2, 1, 3, and 2, 1. So 0, 1, 1 up, nothing across, and then 1, 0, 1, 1, 1, 2, and 2, 1. Yeah. Okay. Backwards L is going to be 0, 0. Whoops. It's not a 0. 1, 0, 2, 0, 2, 1, and 2, 2. bar is going to be zero, zero. Oh, there's an interesting thing here. Is there an interesting thing here? No, it's fine. I was thinking about whether, like, we're measuring everything from the bottom left-hand corner, so the bottom left-hand corner is 0, 0. I was thinking about whether anything, like, the starting position was measured from the top, but it's not, so it's fine. And then the square is 0, 0, 0, 1, 1, 0, and 1, 1. Is the square. Okay. Okay, so that'll get us the stone. So basically the plan will be, if there's no square, then or if there's no rock falling, then when we step, we instantiate a new rock. If there is a rock falling, we're either doing a wind tunnel, or and actually that makes me think I need something else here, don't I? I need and rocks fallen. Simulation phase. Something like that. And the simulation phase will be an enum of nothing falling, or I guess since I'm going to change it at the end, it should be new rock, jet or fall, we'll say. The handle jet and handle fall. Yeah. And then, so when we start up, we need to simulation phase, new rock. Okay. So we're gonna need the step function, but we need some other like getters in here first. So what do we have? We have pub function. Get height. We're gonna need get nrocks. It's easy because we're tracking it. So this is just usize self dot nrocks fallen. Let's go ahead and rename this to match our variable. Alright, what else do we have? Let's mark this as implementation and go check our test here. Mark this as test. So nrocks fallen. Why are we on hat? Oh, we're not. Okay. Get falling position, get time elapsed. Okay, time elapsed and falling position. We probably need falling position too, don't we? Time elapsed. And I think let's see here, we're gonna want to say jet pattern next jet pattern IDX will be a U size. Let's move this up and this up. Maybe this goes first, because everything else is like mutable essentially. And then time elapsed and rocks fallen. Next rock, next jet pattern, rock position is a vec 2, but sometimes there's no rock position at all, so option vec 2. Actually, what we can do is we can have the simulation phase. Position option 2. Now there are some invalid cases though that I'm not wild about. Because now simulation phase and rock position are redundant, or there are some invalid states. So what's a nice way to model this? Also, we're starting to have a lot of things in this simulation, which isn't that exciting to me. Rock position. I guess this can just always be a vec 2, and no, then it's redundant. I don't like that. So one way we could do it is in the simulation phase, if it's a jet. Or if it's a rock, we can have the rock position as part of it. Yeah, maybe that's the best thing. Okay, let's just do that. So handle jet, vec 2, vec 2, and here we can impulse simulation phase, function get rock position, at self option vec 2, match self new rock, then there is no position, so that's the none case. Otherwise, handle fall or handle jet should both be these aren't copy, right? If I do this, it doesn't work. Can't remember why those aren't copy, but they're not. Okay. I've run out of coffee and I'm only 53 minutes into the stream. I don't know if that's a good sign or a bad sign. We'll find out. Okay, so now we need to reorganize a few things. So let's move that up. Simulation phase new rock, good. Next jet pattern IDX will be usize. Sorry, will be 0. And now that works. Okay. Now get time elapsed works. Get rock position. Vec2 has to be an option, Vec2. And we say self dot simulation phase dot get rock position. We also have get rock type, and for that, we need self.rock. So really want this to be falling rock, which we could just rename. And rock should be copy. Should probably be hashable also, although I don't think it's going to matter. Okay. Fair point. Match self.phase. Simulation phase new rock. Then yeah, then none. Anything else, then falling rock. Okay. See if you hear simulation. What am I? I'm like misspelling something. Wait, it doesn't think it exists at all. Oh, I screwed up some. I'm missing some bracket somewhere. Simulation, the bracket's never ending. This ends, this ends, this doesn't end. The match. Bingo. Okay. Relative stone positions. Takes one argument. It needn't. Okay. Alright, what are we missing? Get falling rock type. We're not missing it so much as we need it to be So anytime that we have get falling rock type, comma, space, anything, end paren, we want to replace this with get falling rock type, start end, sum this. So close. Get falling rock type doesn't need us to be escaped, I guess. Sum this. End paren. Does that look right? It does. Hey, nice. Got it in one. Okay. We need falling position. Get falling position. I already implemented that. I just called it something different. What did I call it? Get rock position. Should probably be get falling rock position. And then down here, we just want to say get falling position, get falling rock position everywhere. Okay. Why didn't that do, why wasn't that global? Because I didn't make it global. Or get falling rock position. Get falling rock position. Okay. So it's percentage s, get falling position, get falling rock position, global. Good stuff. Okay. So now we just need get height, step, and step until rock lands. So get height is easy. The function get height, usize, and this is just self.occupied squares dot keys dot map v dot y dot max dot unwrap or else unwrap or 0. Actually, unwrap or default is 0. Unwrap or default. Yeah, let's be explicit. I think being explicit is good. And we don't like this y, because y probably isn't the right type. Y in theory can be negative. We know it's not. This will result in a annoying error. So we want to do b.y.try into usize, and then unwrap. Try into, sure. Nice. Okay. And let's just split this out. Okay, so that should be get height, and then we need step, which is at mute self, doesn't return anything. Okay, so here we want to match on self dot phase, simulation phase. Phase, new rock. In that case, we want to say, and there's another issue. We actually want the previous falling rock to have been the last rock, which is square. Because we're going to start in the new rock phase. So we want to say let new rock be self.rock, self.falling rock dot get next. New phase is simulation phase, handle jet, new rock. New rock position, which is always self.get initial get falling rock initial position, which will be get falling rock initial position. Doesn't actually need to take anything. And this is always just vec2 new. 2 from the left, 3 from the... Oh, it does need 2. It does need 2. Self. Self dot get height plus 3. As I32. Okay. Get this out of the way, by the way. Alright, so that gets us the new rock, that gets us the new phase that we're in. What else do we need? The jet will take the jet. So falling rock is going to equal, so we can just say self.falling rock equals this. And I think we can just say self.simulation phase is this. And jet patterns we don't need to update. Time elapsed we should increment. Nothing gets, yeah. And number of rocks fallen we can increment there, I think. So let's say self.time elapsed plus equals 1. And self.rocks and rocks fallen plus equals 1. Alright, so that's one case. Next case is handling a jet. We have the rock position. And in this case, we need to let jet direction be self.jet patterns. Next jet index, self.next jet index plus equal 1. And then we need to move the rock. So we'll say self.move rock, falling rock, jet direction. Does anything else need to change? Yes, the simulation phase needs to get updated. Number of rocks doesn't change. Jet patterns doesn't change. Occupied squares will change within the move rock. So we just need to... What did I just say needed to change? Time elapse, simulation of falling rock. Occupied squares. Oh, the simulation phase. Right. Simulation phase. Actually, I'm gonna move this up and this up. I want them just visually. I want them all to end in simulation phase. Handle fall. Oh, actually, we're gonna update that. We're gonna update that within move falling rock. Are we? No. We're gonna. I really like having like a whole lot of nested mutable things going on because it tends to be confusing. So we could say get movement effect, and then this will be let new falling rock position, or let new phase, and what else has to change here? Anything? Occupied squares. But occupied squares won't change until we hit the floor, which we never do here. It's really just simulation phase. I don't know that I love this API, but let's see how it goes. Okay, yeah, movement effect. Self.simulation phase is new phase. Let's put this here, and let's, just for visibility's sake. Okay. And then last but not least, handle fall, rock position. And here we just want to say let new phase be self dot get movement effect, direction down, and self dot simulation phase equals new phase. But what might happen is we might have hit the bottom. So maybe it's just get new position, and then this is always going to be simulation phase, handle fall, position, new position. This one though will be new position, and then if rock position equals new position, that means it didn't move. in which case it's landed and we need to handle that case. Otherwise, we go to simulation phase, handle jet, new position. And we just need to handle this case of rock position equals new position. So at the end of this, it's going to be simulation phase equals new rock. But first we need to turn the rock into stone. And so what we're gonna say is, let's see here, I'll move this down. Wait, this isn't quite gonna work. This isn't quite gonna work because we're not gonna know. We're gonna hit one too many jets. Like, let's say that it lands on a rock, then first it's going to go down and land on the rock technically, in which case it should stop. But it's not going to know that yet because it's going to move down. So then we're going to get one more jet, and then it's going to handle the fall and realize that it's hit the bottom, which we don't want. That's not what we want. So what we want is if self dot falling rock has landed, then else something else. So in this case, we're going to get the simulation phase new rock, but we also need to say self dot occupied squares dot extend at mute self dot falling rock dot get stone positions new position. True. And I guess I don't need this to be this can just be a hash set. And this can just be a hash set. If it's in the hash set, then it's occupied. And so this is just iter. And what else? Yeah, movement effect and falling rock has landed. Hasn't happened yet. Okay. Is that everything that has to happen if it lands? Occupied square, number of rocks fallen. Simulation phase gets updated. That looks fine. Okay. Let's say somewhere up here we should have of function step until rock lands. And this will just say loop if self dot simulation phase is new rock, then return, and otherwise self.step. What's the issue here? Oh. That I didn't drive anything for these. Copy is not going to work. Default is plausibly going to work, but okay. And in principle, this can be hash. Okay. Now, falling rock has landed. Falling rock has landed. And the thing to say here is whether is self dot falling rock dot get stone positions let's say self dot simulation phase dot get rock position dot expect. We shouldn't be checking whether the rock has landed if it's a new rock. Let's definitely break this out into some nicer things. Okay, get stone positions, and we just want to say whether this intersects or is disjoint. Nice. With self.occupied squares. But we want the inverse of this. We want to see if they've intersected. Okay. And then the other thing we need to do is do the get movement effect. So for that we'll say get movement effect direct, let's see here, self direction back to, and here we want to say oh wait, there's one other case here. If okay, there's one other case here. Let's pop this out and say let rock position be this. And now get stone positions, rock position. But we want to say that if rock position dot y is 0, return true, because it might just be on the floor. If it's on the floor, we're done. Okay. And then the movement effect is going to be the movement effect will be self dot so I guess we can just do the same thing because I want the helpful error message. And we want to say let new position be rock position self dot falling rock dot get stone positions rock position into that's not right. New position is just rock position plus direction dot get delta. But then we want to check whether it's intersected anything bad. And so we want to say let rock squares be self dot falling rock get stone positions new position. We want to say I guess we can say we're never gonna have direction be direction down. And we can say if direction is direction, sorry, we're never gonna have it be up. If it's down, then the only thing we need to check is is this. So maybe falling rock has landed. What we do is we actually say this. we keep this. We say if it's down, then we return self dot. We return rock position. Otherwise, if they're disjoint, we return so here we're gonna get rid of this. I'm gonna move this up. We return new position. And if not, which I guess we can safely make this an else if for readability. If not, then we return rock position. Falling rock has landed, then becomes self dot rock position. Let's see here. Self dot get movement effect. Direction down. Equals self dot simulation. No, equals self dot simulation phase dot get rock position. And we can just unwrap this one because it'll fail within the function first with the nice error message. And now down here, we know that it's either going to the left or to the right. So we can get the stone positions, and then we need to check if those run into, so if, let's see here. If rock squares not rock squares is disjoint with self dot occupied squares, then return rock position. It doesn't move. If rock squares dot any v dot x is less than 0, or v dot x is more than max x, then we return rock position. Otherwise, we return new position. And here we can say const max x. U size is 7. So it's 7 wide, which means positions 0, 1, 2, 3, 4, 5, and 6 are okay, so it's greater than or equal to max x, I believe. All right. I don't love the names for these. Let's call this original position. And let's call this potential new position. And this needs to be as I32. Okay. We have one little thing going wrong here, which is just that our input type is different. And we're compiling. So, do I think this test is going to succeed? Well, it's meant to succeed. I'm not sure I'm convinced it's going to, but let's find out. Fails. Get falling rock type before any rocks have fallen is in fact meant to be none. Let's just say this is minus rock minus, and then do I test that somewhere else? Stop until rock lands. So at the time when the rock lands, it should now say none. No rock is falling, and some plus, and this should be none. Yeah. Okay. Still fails. Get falling rock position. Sure, okay. This equals none. I mean, that's fine. That is right based on what I implemented. I'm just thinking about how to test it better. I guess I can say simulation dot get occupied squares is what was it? 2-0. So back to 2-0, back to 3-0, back to 4-0, back to 5-0. And step, that should be fine. This one's going to be none again. And so instead we can do something like, I mean, the height is kind of checking this for us. So this should be 5. No, it should be 9. And maybe we want to say we want to make sure that the very top of it is present, which will be 0, 1. Make sure I index this right. So 0, 1, 2. So 2, 1, 2, 2. So 2, 2, 2, 3 should be occupied. Simulation.get occupied squares.contains vec2, 2, 3. Pretty sure this needs to be a reference. And then we'll say it doesn't contain 0, 1, 2, 3, comma 1. And it doesn't contain 4, comma 3. Three comma 3. I'm pretty sure I have off by 1 errors here. Just looking at how I'm counting this out. So, okay, let's get falling rock position or something. We'll say pub function get occupied squares hash sets of vec2. I guess we'll let the caller decide whether to clone it or not. Self.occupied squares, and now at the bottom here, I think we have to do some cloning. Oh no, we don't. Yeah, just this one. Let's see here. This needs to be dot. I mean, we can say dot clone dot into iter dot collect. And let's just break this out a little bit. Okay. All right. So we think the occupied squares are, these can't be vectors. Doesn't work. They have to, we need to compare them as okay. Time elapsed, it's saying is 9. Do I believe the time elapsed is 9? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, I do. I think I didn't count the things before, so this should be 10 now. And this should be, I didn't say anything about it, which is fine. Okay, get height is returning the wrong thing, and I buy that. This was one of the off by one errors I was pretty sure I had, because the height is going to be +1. And falling rock position is 4-3. Oh, that actually seems close to correct. Not quite correct, though. I think it should be 3-3. Should be 2 above the highest point. But again, there's an off by 1 error here. Is there? It's meant to start 3 off of the tallest thing. So at the beginning it's 0, and it starts 3 higher. So 2-4 seems right. Okay. Occupied squares is only 8. That's wrong. For sure that's wrong. Because the second thing that falls has 5, yeah? Yes, that's accurate. Okay. So something's not quite working right in the collision logic, I expect. Type today. Invalid format string. Is that an invalid format string? This would be valid, yeah. Am I blanking on... I never thought it was that. It's not. Can't be formatted. What is the debug formatter? String. You're crazy. So it's this. Expected an end. There is an end bracket. What am I doing? Oh. Yep. That would do it. Okay. So it has 30, 20, 40, and 50, which is correct. Then it has 2-1, but it also has 4-1 and 3-1, which is wrong. So basically the plus sign has sunk into the minus sign, which is bad. So let's so does that mean it's not detecting that it's landed somehow? Oh, why am I doing it this way? Position. Interesting. I actually never use rock position here. That's okay though. Yeah, the reason it's in there is to avoid. It's to avoid redundancy in the type. So that's fine. So if falling rock is landed, certainly seems like what we would want it to be. Occupied. Oh, but okay, has landed, but we haven't moved it yet. It's if it's about to land. So So I guess what we can do is we can say this, but then immediately update it. If it's landed. So get occupied squares now. When it first lands is showing up incorrect. So we're saying 3, 4, 5, 6. So the initial position is 2. Zero, 1, 2. So 0 is a valid position. Less than 0, so that's right. So then at the end, when it lands at 0, 1, yeah, it lands at 2. So now this is wrong, because this has it landing at 3, which it doesn't. So falling rock starts at 2, 3, goes to 3, 3, goes to starts at 2, 3, goes to 3, 3, goes to 3, 2, stays at 3, 2 because it gets stuck against the wall. So that's correct. It falls again to 3, 1. It should get pushed to the left one more time before it falls. It's as though it's coming to rest one step too early. So it starts at 2, it just started at 2, 4, not 2, 3. By this measure. Yeah, so we want it to start at 2, 4. 4. 3, 3, and then it keeps going. I'm actually going to put in the other cases. So 3, 3, 4, 3, 3, it falls. 3, 3, it stays in the same place. 3, 2, it falls. 3, 2, 2, it falls, and then 2, 1, it lands. No, that's not right though. 2, 2, this should be 2, 0. No, it should be 2, 1. It should be 2, 1. And then that should mean that it fell all the way. Okay, so initial position should be self-deck at height plus 4. If it starts at 2, 0. Once its height is 1, then it should start at 2, 5, and so on. And now what happens? Okay, so now it starts at 2, 4. It goes to the right. It drops 1. It gets stuck. It drops another. It goes to the left. But computer doesn't like that. Looking at the example, starts, goes to the right, falls, goes to the right but nothing happens, falls, goes to the right but nothing happens. Okay, there's a whole extra go around here. So that's the nothing happens. So then nothing happens and it goes down one more. So this should be 2, 2. No, 3. 3, 2, 3, 2. And 3, 1. And then 2, 1. It goes to the left. Oh. It's when it tries to fall. So 2, 1, 2, 0. And now it should have fallen. Except that at this point it should be none. Because it landed. But now these should be, yeah, those are all right. So it does get pushed to the left. I'm looking at this. Even though it gets pushed to the right, nothing happens. It falls 1 unit, it's on the bottom. But a jet of gas pushes it to the left 1 more time, and then it stops. So that means that the collision test, oh, and it's 3 o'clock, so I gotta wrap up soon. That means that my collision test is happening incorrectly. So it is this. So 2, 1. Okay, so it starts here, goes to the right, falls, gets stuck, falls, gets stuck, falls. Zero, 1, 2, 3. Okay, so I'm back to thinking that these should all be 1 lower than they are. And then like this. Okay. But now we're winding up with the rock back in the ground. Okay, I gotta wind up here for the day. So we'll stop here. I think we're pretty close to having it sorted. It's just the kind of details of exactly how things are indexed. Those are always fun little off by 1 errors, fun little details. But that's what tests are for, making progress. We will start here next time, which probably won't be tomorrow, but might be, but in the next few days. So hope everybody's having a good day. If you haven't yet, please follow. You can check out older videos on YouTube, and yeah, it's snowing here. Hope the weather's interesting everywhere else. I gotta do some shuffling later. All right, take care.